All right, so again, this is number 13. We're going to do the side that's got the 2 and the 4 terms. That'll build us up to where we go with 3 terms tomorrow to do what we need to do with these. All right, so very first thing, before we do any of this, before we get into the other parts of it, we're going to back up for just a minute and just make sure everybody remembers how to get a greatest common factor. And we're going to do that with the 2 terms just to make sure everybody's good first. Okay, and in 2 terms, this again, there's basically 2 cases, 2 things you're looking for. First thing in any of this factoring we're going to do, you always look for a greatest common factor first, whether that's 2 terms, whether that's 4 terms, whether that's 3 terms back here. That no matter what you do, you're always going to look for a greatest common factor first, and that's the very first problem that we're going to do. And if you're doing a greatest common factor problem, maybe something like this, where you've got a 2x to the third minus 6x squared. Okay, and what you're going to do is basically, all right, if it's 2 and 6, what number can I divide into both 2 and 6? We can divide it 2. Okay. Now, if you forgot variable-wise, when you're going through these, you always take out the smallest amount of variables, because if you got x to the third, which is 3x's, x squared is 2x's, you can take 2x's out of this one, but you can only take 2 because this one's got 3, this one's got 2, so you can only take out the smaller amount, so that would be 2x squared. Okay, and if they just say to find the greatest common factor of some terms, that would be the greatest common factor. Now, after that, they're usually going to say then the factor completely. And if you're working with a greatest common factor, then what you basically have to do then is go back and divide each term by that greatest common factor. Okay, so 2 divided by 2 is 1. If we've got x to the third, take out 2x's of x squared, that's going to leave us with x. And so basically what we're going to do then is we're going to take whatever we get for this part and put that here. So 2 divided by 2 is 1, and we'll have an x left over. Okay, now, and since it's 1x, you don't necessarily have to put the 1. Main thing is that we just put the x there. The 1's kind of understood, so we don't necessarily have to put that. Okay, and then we'll do the same thing over here. 6 divided by 2 is 3. We've got x squared and x squared. They knock each other out because of the terms that's there. So then it would just be x minus 3. Okay, so then that would be your final answer. All right, so now the main thing we're going to look at is the second part, which is the difference of perfect squares. And I'm just putting this just to separate, the problems we're looking at. And these are problems that will actually be easier than the greatest common factor ones. So this is actually the 2 terms with the difference of perfect squares. This is probably going to be the easiest factoring that y'all get to do because it's the one that you have to think the least amount on. Okay, because if it's difference of perfect squares, the first thing is there's going to be a minus in between the 2 terms. Okay, and what makes it perfect squares is that with x squared, it's going to be x times x. Okay, and then 49 is 7 times 7, right? That's a perfect square number. It's 7 times 7. It's 5 times 5. It's 6 times 6. 11 times 11, something like that. And if that's the case, then here's what you're going to do. So we're going to need actually 2 sets of parentheses here. So what we're doing is like reverse full method. If you remember doing the full method, we're basically doing reverse full method. That we're going to put the x's that's here, they're going to be first in the parentheses. The 7 is going to go last in both parentheses. And since it's a negative 49, the only way to get a negative is that if one of these numbers is positive, the other one's going to be a negative. And there you go. And that's it. That's all you got to do. And you're like, well, they all can't be that easy. Well, they actually gets pretty close there. So let's say if it's y squared minus 100. All right, y squared is y times y. 100 is 10 times 10, right? So when you go over here to factor it, we're going to make one of them y plus 10, and the other one's going to be y minus 10. And somebody's thinking, well, does it matter which one goes first? Absolutely not. If your answer is y minus 10 and then y plus 10, that's okay. As long as you've got a plus 10 and a minus 10 in there somewhere, the order doesn't really matter. I just kind of just, me, force of habit, I always seem to put my pluses first. Now, if the first term happens to not be just 1, like just x squared or y squared, it can still be a perfect square, even if it's got some other numbers with it. So if you're doing 4t squared, okay, that would be 2t times 2t. 81 is 9 times 9. Okay, so if we go for this one, instead of just being a t, it's going to be 2t, and then one's going to be a plus 9, the other one's going to be a minus 9. All right, so far so good. You're thinking, all right, I like those, right? Now, if the first term happens to not be a perfect square, so if you get one like this, where you've got 2x squared minus 50, and you're like, ooh, that's not quite a perfect, it's not a perfect square, that's not a perfect square. So if they happen to not be perfect squares, then now we're looking for a greatest common factor first. So if it's 2 and 50, divide both by 2, right? So make it 2 times 2 divided by 2 would be x squared. 50 divided by 2 would be 25. Okay, and if we ignore the 2 for just a minute, perfect squares, right? So now we can do x times x. This one is 5 times 5. And if the 2's out front, the 2 just stays out front. It's going to be 2 times x plus 5 and x minus 5. Okay, so there's your basics on all the difference of perfect squares. And again, that's, as far as basics go, that's about as hard as it gets. That if you look at the numbers and you go, there's no perfect square there, then that's where you go, all right, well, let me just take out the greatest common factor, and then, oh, look, now we got perfect squares, and then we can break up that part to get the answer we're looking for. Now, here's where they take it up like one more level for this one. Let's go x to the 4th minus 36. But you may be going, well, okay, it's got to be perfect squares. That's not a square number. Nope, it's not. But because we know 36 is 6 times 6, so we're good there. But if it's x to the 4th, couldn't we do x squared times x squared to get x to the 4th? Okay, so it's also even though it's not a square term here, basically if your x, whatever variable you're looking at, as long as it's an even number, 2, 4, 6, 8, 10, that kind of thing, it's always a perfect square because you can just cut it in half. Question here. If it happened to be an odd number, you'd probably have another x over here. So if you had like x to the 5th and x on this one, then you could take out a greatest common factor and just put like an x out here to do something like that. So it's possible it could be that way. Probably on those, I don't know that you would see any like that where they're not already x to the 4th or x to the 6th or something like that. Okay, so if we do that, we've got an x squared plus 6, and then an x squared minus 6. Okay, so now if you look at the next part here, that one's a plus. We couldn't do anything with that one. If that one happened to be a 16, should have picked that number. Didn't think about that. If that had happened to be a, and we're just going to, you don't have to write this down. We're just playing a what if here. If that had been 16, now you got that this is x times x. This would have been 4 times 4. Then you could have gone one more step and made that x plus 4 and x minus 4, along with the x squared plus 6 that would have been there. Or technically that would have been 16 if that would have been a perfect case there. So just realize that on some of these problems that once you break it down and get it here, if this number happens to be a perfect square, again, you can take it and break it down one more step there. Now, in that case, it didn't, so I'm going to get rid of that because I don't want that hanging in there, just to throw anybody off. So that was just a what if we had there. Oh, now one more what if. Actually, y'all can add this one in. What if this had been y squared? What's the only difference in the answer? That now the sixes, instead of just being 6 and 6, they've got y's attached to them, right? So that would just be 6y and 6y. So in your answer, you just put a y there and a y there. So if they give you another variable on the second number, in the parentheses, every time you have that number, you just put that variable with it there to kind of make what you got. So you can just pretend that that wasn't even there, break it down and make it x squared plus 6 and x squared plus minus 6. And if there happens to be a variable, you just add on that variable on the end of the terms that's there. Okay, so everybody all right with the two terms? And that one, again, that one kind of steps it up a little extra on that one. Most of the problems you're going to get are going to be something like this, though, where it's either greatest common factor or it's just a quick difference of perfect square numbers. Okay, so the two terms are always just kind of separate because they don't really fit in any of the categories. Now, everything else we're going to do, the four terms and the three terms, all those things are all kind of interrelated for the most part. And we're going to hit the four terms first, and then tomorrow we'll come back and talk about the three terms a little bit more. So with four terms, we're going to look at, we're still always looking for greatest common factor first. We're going to do factor by grouping as we go through this one. Okay, so four terms, factor by grouping. The very first thing is you're going to group your first two terms together, and you're going to put parentheses around the first two terms. Because what we're trying to do with this is we're trying to get an answer that looks something like this, where we've got two sets of parentheses in our answers that we're doing. Okay, so we're going to group the first two terms together with a parentheses. We're going to group the last two terms together. And then one thing you can kind of put in here, I always forget to put this one. Let me go back and fix this. We'll say always put a plus between the parentheses. So no matter what the terms are, because sometimes the terms get off on these a little bit, because some people are like, what if that third, what if that, when we start grouping this one, what if this one has a minus on that first term? It doesn't matter. You always put a plus in between it. If there's a plus already there, that's great. If there's not one, you need to put one between the two sets of parentheses as you go through this thing. Okay, and then step three, we're going to factor out the greatest common factor, just like we did back here with this one. From the first two terms, we're going to do the same thing in the second two terms. And then here's a built-in check for this when we do factor by grouping. What's left in the parentheses must be the same. And that's kind of huge. Now here's the thing. If it's not the same, you know you did something wrong right off the bat. So if you do factor by grouping and you group some stuff together and the two parentheses aren't the same after you take out the greatest common factor, that way you know something is wrong. You didn't do a greatest common factor, or your multiplication or your division stuff was wrong. So it will let you know that, hey, something's off, because these two things have to be the same. And then once you've got that, then you basically just combine these two things together, and then it's all kind of set up for this thing. All right, so here we go. Let's give an example on this one. This one, we're not going to worry about any minus signs, just to make it a little bit easier on the first one. As we work through a couple of these, we'll make it so we get more negatives involved. So we'll go 2x to the third plus 3x squared plus 8x plus 12. Okay, so again, step one, we're going to take the first two terms, put them in parentheses. And we're going to put a plus. Now, if the plus is already here, we can just write that as 8x plus 12. If that was a minus, that minus would have to go inside here, and then we'd have to put a plus there. Basically, we need a plus negative, if you think about it that way. Okay, so there's our first two terms. We've got a plus in between the parentheses. So now we're just going to do GCF. If it's 2x to the third and 3x squared, there's nothing in common with the 2 and the 3, but we do have x to the third and x to the second, so we can take out two x's. Okay, so if we take two x's out of this one, that'll leave us with just 2x. This one, if we take the two x's out, it'll leave us with the 3. Okay, 8 and 12. That one, we can divide it by 2. Now, here's where the built-in check comes in. And don't write this down, because this is going to be wrong. If somebody looks at this, go, oh, I can divide that by 2. And then they'll go, all right, 8 divided by 2 is 4, 12 divided by 2 is 6. And then when you get to step 5, it says what's in these two parentheses has to be the same. And if you get here and you go, well, they're not the same. Well, then that lets you know something is wrong. You didn't do the greatest common factor correctly. And hopefully you go, well, that's it. Oh, that's another even number. So I can actually divide this thing not by 2. Yeah, greatest common factor would be 4. So then if I divide it by 4, now I've got 2x. 12 divided by 4 is 3. And now I've got the same thing in the parentheses. Okay, so with 4 terms, the great thing is it's got a built-in check that if you take out the greatest common factors and the parentheses aren't the same, you know you did something wrong. So then you can go back and fix it. And you go, oh, okay, I just need to do this or something. And usually you can look at it and say, all right, I can figure it out because it's something easy. Now you've got the same thing in the parentheses. All you're going to do is you're going to take whatever these first 2 terms were that the greatest common factor you took out. They'll go in one parentheses together. And whatever this last thing was that was the common part here, it will just fall in behind it and be what we've got in common there. Okay, and that is what we're looking for. All right, let's do at least a couple more of those. Question, go ahead. That we're going to take the x squared and the 4, put them together in one parentheses, and then this one's just going to follow back behind it.
So you always put that parentheses, you have things in front of the parentheses?
Yep.
Okay.
Yep, so whatever you have in front of the parentheses, they'll go together in one parentheses, and then whatever you have falling behind it, they'll go in the next parentheses. Okay. All right, let's do another one of these just to practice a little bit. Similar numbers, but we're going to change some of the signs up just a little bit. Let's go 12x to the third minus 3x squared minus 8x plus 2. Okay, I'm going to go out to the side over here because I'm going to run out of room if I don't. So if we put the first 2 together, that is 12x to the third minus 3x squared. And again, we always need a plus in between them. And if it's a negative 8x, that means that negative has to go on the inside with the other number. So we need a negative 8x there, and then we need the plus 2 there. So again, you have to have a plus in between them. If you don't have a plus, then again, we're basically just going to rewrite this as plus negative 8x and go from there. Okay, so with those 2, we've got 12 and 3. We can divide them both by 3. We've got x to the third and x to the second. Again, we take out the smaller amount of x's. So 12 divided by 3 is 4. Take out 2 x's. I lose 1 x there. 3 divided by 3 is 1. And we'll take out the x squared, and it's all gone. Now, and again, you must put that 1 there because if you've got 2 terms here, you still got to have 2 terms here. So we do need that 1 as a placeholder. Okay, now, and here's one where it's okay if you want to cheat a little bit, because if you factored this one off and you're good with that answer and you look at that and you go, yeah, I'm solid with that being a 4x minus 1, then you know that the other answer back over here has to be 4x minus 1, right? Because they have to be the same. So if you're good with this factoring and you feel solid about that one, then you know that this one's got to be the same answer. So to get from negative 8 down to 4, we're going to divide by negative 2. Okay, now, and if you had done that one, let's say you were doing this one, and we'll just back and do what if here. We were doing this part of it, and we got to this part of it, and let's say we were going through this one, and you said, all right, well, this is negative 8x plus 2. Let's say you just took out a 2. You left that as negative 4x plus 1, which a lot of times is what you'll do. You'll get to this one, and then you'll go, well, wait a minute. I've got the right numbers, but the signs are wrong. So if you have the correct numbers, but the signs are reversed, then that means instead of taking out a positive 2 on the second one, that's where we should have taken out a negative 2, because then that'll change that to a positive 4. That'll change that to a minus 1. So if you have the right numbers, but the signs are wrong, instead of taking out a positive, that means you need to take out a negative. Or maybe you took out a negative, maybe you should have just taken out a positive. So it's just a matter of kind of matching those up. Okay, and then again, these two greatest common factors will go together in one parentheses. And then the common part we had back here will follow in behind it. And that'll be our final answer that we're looking for. Okay, and with 4 terms, it's always going to be that same exact set. There's no weird anything you can do with 4 terms. It's always group the first 2 terms together, group the last 2 terms together, group the first 2 terms together, group the last 2 terms together. And again, usually the biggest thing that people will mess up on that one is either one, they don't take out the greatest common factor. Back here, instead of taking out 4, they'll take out a 2. A lot of times, if you got negatives involved, it's taking out a negative or not taking out a negative, just depending on the numbers and how it's set up there. Okay. Now, what we're going to do, we're going to throw a couple of special cases at you that don't really fall into the 2 or 4 terms. Because unfortunately, it's still 2 terms, but it's like a special case 2 terms. So on this one, if you want to kind of, and don't put that on this paper, because if you want to put this on a separate sheet, because it doesn't really fit in with this one. And there's another special cases one that we'll do again tomorrow. So if you want to make another sheet that's all just special cases, then you can do that one. Because we'll do a little bit of it today and we'll do a little bit of it tomorrow, just because they don't really fit on the sheet, because they're just special cases here.
Are we numbering books on this blue paper?
Yes, blue paper is 13.
13?
Yeah. Okay, so for the sum and the special cases we're going to do for the one today. And again, we've got some more special cases we'll do tomorrow. But it's the sum and difference of, now instead of being 2 perfect squares, this one's going to be 2 perfect, if you want to call them cubes, not that they call them perfect cubes, but it's 2 cube numbers. So that's sum. There we go. Sum and difference of 2 cubes. Okay, and we'll show you the sum first, and then we'll show you the difference after that. Okay, so and again, we'll make this so it looks a little bit different here in just a second. But just the basic, like their formula that they give to you for this one is basically this: if you have something cubed plus something cubed, this is what the answer is going to wind up being. It's going to be A plus B. So if it's A cubed and B cubed, the very first parentheses are going to have A plus B. All right, second parentheses is going to be A squared minus A times B, and then plus B squared. And usually people go, all right, what else we doing? That's it. And this is one of those, again, it's a special case, so you don't really use this one a lot. And it's one of those weird things where we'll talk about it now. It probably really won't pop up again until we get into pre-cal with some other stuff that we'll do. So this is one of those things you won't see a whole lot. Now, here's the problems that you'll actually see. Here's an example. Most of the problems will probably look something like that, where you've got x to the third plus 27. All right, so the x to the third is good. That part's fine. It's the second number you've got to figure out. The 27 Well, if you check 27, that's 3 times 3 times 3, so that would be 3 cubed. And so basically, here's what you got to do. Everywhere you have an A in this formula, you need an X. Everywhere you've got a B, you need a 3. So the answer is going to be A plus B, so that's going to be X plus 3 times, so again, the A is X, so that's X squared minus X times 3 plus 3 squared. Which means there's really not a lot to this one that you have to clean up other than just one little thing here. So that'll be X squared minus, we're going to write it as 3X because that's where we're normally used to seeing it. And our 3 squared becomes 9. And that's it. And most people go, I don't like that. Well, yeah, because it looks like there should be something else that you could do with it, but there's not. So it's one of those things of, okay, here's the formula, and all you're going to do is you're just going to take out whatever variables they happen to give to you as you go through this one. Okay, are you going to use this a lot? No. Are you going to use it occasionally? Yes, just every now and again you'll do that. All right, now let me show you one for the minus, because the minus is almost the exact same thing. It's just there's one minor little difference to it. So this is the difference of 2 cubes. So back here, this was the sum. And now we're going to look at the difference. Okay, and the only difference, get it there? The only difference is instead of it being a plus, it's a minus. And as far as the numbers go, instead of being A plus B, this one is A minus B. It's still going to be A cubed. It's still going to be B cubed, but in the middle, instead of it being A minus like it was before, now this is going to be A plus AB. And in this one, instead of it being, or it's still going to be a plus. So the only difference between the two formulas, all the numbers are the same here and here, but they'll fit. The only thing that's different is you flip-flop the first two signs. This is plus minus, this one's minus plus. Question?
Why is the first negative change with the second one?
Because if this one's b squared, to get down to a negative b the third, then we need one. Basically, it's like doing the full method. That if we went back and did the full method here for this part and this part and this part, and did distributive property through all this, all the terms would cancel out. So it's just a matter of just getting the signs correct to be what's there. So, all right. So if you have y to the third minus 125, and I ask you to, factor this thing, the y to the third is good. And again, the 125, just got to figure out that that would be 5 to the third. So everywhere you have a y, that would be the a part. Everywhere that you have a b, that would be the 5. So this is going to be y minus 5 times y squared plus y times 5 plus 5 squared. And if you want to kind of, as you're working these out, if you go, well, that's y times 5, let's go ahead and make that 5y. If that's 5 squared, you can make it 25. And again, I'm just writing this out to make sure that, we've got everything there, so we're not skipping any steps to make sure that, the flow is there. Okay, let me show you one more. Okay, so for this one, we'll do 8x to the third minus 27, where that it's not just a variable on the first term, where the first term has got more than the variable. It's got a number with it too, so coefficient. Okay, so 27 would be 3 to the third power. To get 8x to the third, that's going to be 2x to the third power. It's not just x, now it's 2 times 2 times 2 to get to the 8. Okay, so the big difference is we're doing this one, where we've got our formula back here. Everywhere we've got a, now it needs to be 2x. And everywhere that we have a b, that needs to be a 3. So this is going to be 2x minus 3 times. And here's what we have to do, and this is the, I guess, the bad one in this case, because when you have one where this first term is not just 1, if it's 8x to the third, then now we're going to do 2x squared plus 2x times 3 plus 3 squared. Okay, so we got 2x minus 3. If we do 2x squared, that's going to be 4x squared. 2x times 3 would be 6x. And then the 3 squared would be 9. Yes.
Why would 4x still be squared?
Because it's still because if we're taking out the a and replacing it with 2x, it's still the whole thing squared for that term. So it's still not just x squared, now it's 2x squared. So we've got 2 times 2 to make it 4. Because if we went back and did the full method distributed property, the first term has to be 8. So if this was just 2, this would be 2 times 2, that would be 4 for that part. So to make it out to be 8, we've got to square the 2 to get to that part there. Because we're still trying to get this first term back to be 8, where if we don't do squared here, if we make it x squared but leave it as 2, it would be 2 times 2, that would be 4x to the third, and not 8x to the third. So basically, if you've got a coefficient, you've still got to square the coefficient and the variable both to get there.